This is meant a bit as an interactive session. So if you have any questions, don't be shy, but I'll try to walk you a bit through how Elasticsearch uses Java, since it's one of the bigger projects. So we have, however you want to count, GitHub stars and forks, but it's a project that started in 2010, and we have been accumulating a lot of work around that since then. I also recently ran our code base through CLog to just see what we have. And you can see we have 16,000 files. We also luckily have like a lot of comments in our code. And we have sizable amounts of lines of code overall. From our full documentation is part of the main repository. So we have a lot of ASCII doc there. We have all the Java code, YAML, JSON, Gradle, all kinds of things. Yep. All good? Okay, cool. I'll come back to Gradle later on, and if this is a good idea to have more than 300 Gradle files and have like 18,000 lines of Gradle code, but that is a different discussion we can have afterwards. I also quickly ran it through MergeStat recently, where you can see how many unique authors are in the Elasticsearch code base, which we have reached more than 2,000 by now. We have a ton of commits, and we have a lot of people that were active over the years. Though based on the email address, for example, Kimchi and Chai, this is the guy who started Elasticsearch. This is the same person. So some of these stats are slightly off just based on how people configured Git. But it is a very evolved code base over the year. So let's see how we are doing things and how we are trying to keep things fresh and working as they should be. So if you query Elasticsearch, it will tell you the current version is 8.6.1 and whatever build hash, etc. you have. This is how you normally interact with Elasticsearch from the REST API. But today I really want to go beyond the REST API and just see how are we doing things under the hood. So like we said, I'm a developer advocate at Elastic. I mostly go around and speak. I think I've joined Elastic almost 7 years ago, which is a long time. So I've also seen a lot of development and changes over the years here. So one of the first things that we do, and this is maybe a bit less common in the Java world than in other ecosystems like Node, is that we bundle the JDK with our downloads. So if you today download Elasticsearch as a binary, you will also get a full JDK shipped with that. We didn't always do that. In the past, you had to pick a JDK and install it manually, and then you might have had a mismatch in version. So you had an old JDK and things would break in unexpected ways. So a couple of years back, we decided that it would be much easier for the vast majority of people if we actually ship the JDK with our binaries, which is the best tested combination. And what we generally recommend, unless you have a very good reason for not doing anything else. And while in Java, this is not so common, for example, in Node, it's very common that you ship Node.js with your application. We have been always doing that with Kibana, which is the UI that we have for Elasticsearch. There it's kind of the standard. But for Elasticsearch, we only started a couple of years ago, but it has made your life, or our lives and yours, hopefully a lot easier. We are using OpenJDK, and that is really packaged with all binaries. If for some reason you want to override it, you can do that. So you can set an environment variable to actually do that. By now, we don't have a binary where we don't have the JDK packaged anymore, but from the unzipped folder, you can delete the JDK to actually really get rid of it. But then you need to override it by saying wherever you have a JDK running and you want to use that, then you can do that. Just trying to keep up with questions, but it's still around the raffle. Good. I'll continue. Which OpenJDK are we using? So we have been switching around a couple of times in the last year. So we came from Oracle JDK, then Oracle had some licensing stuff, which didn't really stop us, but we had the feeling that Adoptium was having more momentum. So we then switched back from Adoptium to Oracle JDK because it took Adoptium quite a long time sometimes to update their JDK, especially I think the Docker containers sometimes took quite a bit longer to be released for a version. And because we're tied very tightly to the JDK and like all security updates, we didn't really like that. Whereas Oracle is very good at shipping all the binaries very quickly once they're out. That's why we have picked that as our default JDK again, that we are shipping with our binaries. And I'm including quite a few pull requests. We don't have to go into the code details there or anything. It's just if you ever want to look at how things happened or when or why, those are good references. That's why I'm including them. And I'll share the link to the slides at the end as well. One thing that sometimes people are like, why are you using the JDK and not just a JRE? We mostly go for the JDK because it just provides more tooling around heap dumps or the other things that the JDK brings in forms of binaries that you can run. And those can be quite helpful. And then the next question is often like, isn't that very large? And we're like, yeah, but for us, like the size is actually never really the problem. Security, for example, is a much bigger concern. Why is size not such a problem? Maybe if you have something as like an application that is stateless and you deploy that 100 times a day, you care about the size of it. Elasticsearch is really only released every couple of weeks at most, and then maybe you don't even update it that frequently. And also, if you store, let's say, 100 gigabytes of data in Elasticsearch, do you really care how large the original or the binary is that you're using? Because if we have the binary, if it's 300 megabytes or 800 megabytes for Elasticsearch, it doesn't really matter if you then store 100 gigabytes there. Maybe the only place where you can feel it is that our Docker images are a bit larger. If you have that for development and you need to pull in 50 different tools to your laptop and then you can feed it in disk. But again, for us, the size, for example, of our Docker images or the binaries in general is not such a big concern. It is to some degree a bit like the number of dependencies that we have in those Docker images, because security scanners will shout over all kinds of true and false positives in terms of security. So that is an area where we're trying to limit the surface and make our Docker images, for example, smaller. But the size here is not the driver. It's really just the security alerts, because they suck up a lot of time from us, that people say like, oh, you have this vulnerable thing here. And then we're like, no, this is actually not reachable in code. But it is a big distractor, whereas size is something we're willing to accept. So there is this comic in terms of like how big everybody's Docker containers are, or Docker images. I know this has been widely going around with Node.js. There is the number of modules probably that you pull in, but with Docker, it's not uncommon that people have very large Docker containers. But again, for us, we don't really care about the size of the Docker image that much, especially for production, because if you store 100 gigabytes or a terabyte of data on that, that will still, the Docker image size will not be much in comparison to the data that you put there. So we're okay with that. And we're always shipping the latest JDK, which is maybe almost surprising. So we are not going for the LTS versions, but we're really always shipping the latest version, which creates this problem. If you look at the roadmap from Oracle, when they release nowadays a non-LTS version, in September, JDK 18 didn't get any support anymore, and you had to switch to 19 right away. So there is no real overlap. This is a bit of a stress factor for us all the time, because when we do a release, then we try to have a release relatively close by to these, because often they include security updates. And we just need to have, when we release something new and a new JDK is coming, we kind of like try to catch the new JDK just to ship you a version that will give you a bit longer support. But it is a constant change. Unlike, for example, Ubuntu, where you have like 6-month release cycles for the non-LTS versions as well, they do 9 months of support. So you always have like 3 months basically to upgrade. The JDK doesn't do that, or Oracle's roadmap doesn't do that. Once 19 is out, 18 is basically a thing of the past and you need to move on. And soon enough, we'll have that problem again, or opportunity, depending on how you see it, where we will switch from 19 to 20. So we'll need to catch that pretty quickly then in March to move the JDK ahead again that we're shipping. It does sometimes cause friction. So for example, we had a blocker when we wanted to ship once recently, when we were basically waiting for JDK 19 to come out. And we kind of like delayed everything a little bit in our release just to hit like the right JDK version there. In terms of Java features, how are we doing that? So for Elasticsearch 7, the baseline JDK was 8. Since 8, which came out a bit over a year ago, we have been using JDK 17 as the baseline. So we are always shipping the latest JDK. But we're using as a minimum feature set, we're using JDK 17 and have so for a year or so. There's one thing that was kind of like the precondition for that. We have the Java client for Elasticsearch. And before we had an older Java client that had a dependency to Elasticsearch itself, which was very convenient in code. It just had the downside that it had this large dependency on Elasticsearch and Lucene, the library behind it, and everything we had in there. And that also meant if we wanted to increase the JDK version of Elasticsearch, this would also have an impact on our client. And that was something we didn't really feel comfortable with, because we would have basically forced everybody to update their applications to take JDK 17 at least, if they want to use the client and then have that dependency on Elasticsearch. And many people are not ready yet to go JDK 17 plus. That's why for the 8.0 release in Elasticsearch, we have split up the client and the server with a new client, basically a new implementation. So we can still ship the client that you embed in your application with JDK 8 or up. So your application can stay on 8 or higher, whereas Elasticsearch itself as a standalone process requires JDK 17 or up. But our assumption is for Elasticsearch itself, you will be okay to use a newer JDK, because either you just install it just for the Elasticsearch process, or I mean, you might use the one that is built in the JDK, which we recommend anyway. Or for example, if you use Docker images, we will ship the right JDK with that anyway, so you shouldn't really feel any pain. So in your applications, you have more time to upgrade and you can still use 8 or whatever you want. But Elasticsearch itself will need JDK 17 plus. Since a year ago in the latest version, that's the baseline that we've been using. And this is how we have approached it around the clients. And the version matrix of like which JDKs we support in which Elasticsearch version is quite complicated. We have a full matrix of like this JDK version on this operating system and this Elasticsearch version is supported, and then you can figure out what exactly is compatible. But again, ideally, you don't really have to care about that. If you use just a built-in JDK, we'll take care of that for you. And we're all better off because that's the combination we test the best. You don't have to worry about what is compatible, and you don't have to worry when you upgrade. And we then have a full test of or all the combinations that are officially supported from the test matrix are actually tested as well. So we are using Jenkins, and if I would see you in person, I would always ask like, who is still using Jenkins? And then probably more than half of you raise their hands. And then I ask who likes using Jenkins, and then probably nobody raises their hand anymore, which is also kind of us. So we have been trying to get rid of Jenkins for a long time. We almost went to Team City a while ago, but we ran into scaling issues quite late in that migration process, actually, where we had to abandon that. We are now in the process of actually moving to BuildKite. Also because why do we like Jenkins? Because it's so flexible and we can do pretty much whatever we want. Why don't we like Jenkins? It has a lot of security issues, and then we need to rush out some security patches, also because like our Jenkins jobs many of those are publicly accessible. And the other thing is we kind of use Jenkins in a weird way by now. So we don't use the GUI at all. We have everything automated through YAML for Jenkins. And we only really use Jenkins as a runner to run Kubernetes jobs because of our scale. because we have, I don't know, we have like, just for Elasticsearch, like 20, 30, 40, I don't know how many machines constantly building everything, because every single pull request that we get gets built. And it's a huge infrastructure where Jenkins is not really built for that. So we had, for each project, we had to create a different Jenkins infrastructure because the Jenkins master nodes or whatever they are called wouldn't keep up otherwise. So we kind of had to manually shard it. And all of that kind of works, but it's kind of not how Jenkins was intended to work. And we can have a deeper discussion if you want to later on around Jenkins and why we might want to get out. But it's like, I would say it has done a good job so far, and it got Elastic through 10 plus years of building, but it kind of reached the end of where we can take this. And we will hopefully move our infrastructure to BuildKite, though that is probably its own talk about all the trade-offs and the things that we learned, because with so many jobs and operating systems and environments, those are challenging projects many times. And we, in our configurations, we have a dedicated JVM config file. We have basically created our own syntax, how to, or we have our own syntax there, how you can do settings and apply settings. So for example, you could say, I want to set the XMX for my Elasticsearch instance to 2 gigabytes. Or I could say in JDK 17 and only in 17, I want to, in JDK 17 and up, I want to set it to 2 gigabytes. In 17 to 18, I want to set it to 2 gigabytes, or in 17 up, this is the one with up, I want to set it to 2 gigabytes. And that way we can apply a lot of different JVM flags and options based on the JDK version. And we will actually ship a pretty optimized JVM file for depending on the JDK version that you're running. So even if you're bringing your own JDK, you should still get settings that will work well for your JDK. Just thinking in terms of which garbage collector you use, we have changed that over the years. So if you bring your own JVM, based on these settings that we will provide, we will give you the right settings. And you can, of course, override that, because the XMX you might, or you should set manually for your own environment and what you want to use. The versions don't make so much sense, but this is just for an illustration of how you can, in the JVM file, configure what you want based on different JDKs. Also, one thing that we have seen quite a bit is that people threw all kinds of crazy JVM flags at the JDK and Elasticsearch and didn't really test it that well. And that often didn't end so well. So we are maybe a bit conservative, but we try to test all the settings that we do quite thoroughly. So we know what they are doing and which one is having which influence. If you change any of those, be sure to test it properly and only change one thing at a time, so you can actually figure out what one specific change is doing. Otherwise, we've seen plenty of times, or we've seen two things plenty of times. One, you change 5 different settings and you have no idea what you have actually changed, and it works for a week or so until you hit a bad combination of things, and then the JDK doesn't work so well anymore because your combination of JVM flags is just not right for Elasticsearch. The other thing that we have also seen a couple of times is that somebody applied custom JVM settings that work, and then we ship a new JDK, or they update their JDK and they don't change these flags. And then these outdated flags cause some issues. So I would also be careful every time you update the JVM, reevaluate if the JVM settings that you're applying actually still make sense here or work as you want them to work. Which Java 17 features are we using in Elasticsearch by now? So since it's a large code base with, what did we say? I think 2-point-something million lines of Java code alone. We haven't changed the entire code base over yet, but these are some of the things that we have started to use. So pattern matching, for instance, of text blocks for JSON and multi-line strings, and improved switch expressions have started to appear all over the code base. Things that we also want to look into, but I don't think we haven't quite gotten to it yet, is pattern matching for switches, sealed classes, and records, which we have in JDK 17. We haven't just like started to use them widely yet, maybe in some places already, but we have plans to add them in more places as well. So while the JDK allows us to do that, just changing all the code that we have will take a bit longer, and we're not quite there yet. There's also new stuff that is coming out. For example, Lucene 9.4, which came out a couple of months ago, because 9.5, I think, was released just last week. Has in JDK 19 has foreign memory access from Project Panama, which should help with performance quite a bit. However, to use that, you need to enable preview, and they have like a special setting which says if you're on Java 19 and only 19, because I think there's another change coming to that, so we only want to target Java 19 and not 19 and up yet. To allow the new JDK APIs through a preview flag to make use of those. But that's also quite an involved discussion, and any of these flags would mean that we need to bring that change to all the build jobs that we have to make sure those really work the way they do. So that's kind of like just to illustrate how, if a new feature comes out, how do we get it into the product? And it's kind of like a more evolved thing, because like just because a product supports something, then we need to make sure the right JDKs are there, we have the right testing in place, and only then will we actually enable and roll it out. Just because if you have a large enough footprint of installations, which Elasticsearch has a very sizable number of downloads every month, even fringe problems will cause a lot of friction and support cases. So we try to be a bit conservative around that, but still enable cool new features like Panama that Lucene can use to get the best performance out of that here. And yeah, like I said, you need to bring it to the build jobs, and this would be the build job. You can see Elasticsearch CI is the main node for Jenkins jobs for Elasticsearch. And then we have a dedicated job that runs this with the Java preview feature flag to make sure that combination actually works and does what you want. Garbage collection is interesting. And I feel like if you have stateless applications, people are often like quicker to update. We're, again, a bit more conservative just because it might cause larger issues. And the thing to keep in mind when you talk about garbage collection, especially for data stores, is that the trade-off is normally throughput versus latency. And in a data store, you want both. You want low latency, but you also want to have high throughput. The problem is that the optimization has shifted a bit around, and depending on which garbage collector, you might be overly focused on one. So we've historically always used CMS because it had good throughput, but it had stop-the-world garbage collections, which were not so great. And then G1 appeared, and it was kind of useful, and it had shorter garbage collections, but it did impact throughput quite heavily, especially the early versions in 8. And I think there were also some quite bad bugs, but when we detect some very old JDK version with these bugs and you try to enable G1, we would actually stop Elasticsearch from starting up. So there is some detection logic that says, like, if you have this bad combination of things where we know they will cause issues, we have a so-called bootstrap check. We will stop you from running that, though that's very old JDKs, and you probably don't have them, or you shouldn't have them anyway. In any case, CMS was the long-time recommendation that we had. However, it was removed in JDK 14, even though it was the recommendation from our side for a long time, and it worked really well, except for stop-the-world garbage collections. So in Elasticsearch 6.5, which was also quite a few years ago already, since then we've added G1 support officially, also with the right JDK flags to make sure that it does the right thing. And since Elasticsearch 7.6, which came out like 2.5 years ago or so, we have actually switched. I think that was pretty much when JDK 14 came out and almost forced us to. Then we changed the default to G1 GC. So if you're using any current version of Elasticsearch, you will be using G1 for garbage collection nowadays. And that works well, especially with the newer JDK versions. And it's one of the big reasons why we always ship the latest JDK, is just because we have seen a lot of improvement around the garbage collection. And then people come up and say like, oh, we see great results with this other new garbage collector, for example, ZGC, which can give you high throughput, because like I said, latency and throughput are kind of like the two things you need to balance out against each other. And ZGC seems also to be doing good stuff around throughput and very short pause times. However, so far in Elasticsearch itself, we have not enabled that yet. There is an open issue for that. I'm not sure when we'll actually get to that or want to enable that. Like I said, our folks are also a bit conservative, and they keep also saying that a good garbage collector takes like 10 years to develop. And I think ZGC doesn't have 10 years of battle provenness on its back yet. So we are maybe not quite there yet, but I've also heard from some people in the community to test with ZGC that they had quite good results. Whereas, for example, I think with Shenandoah, people didn't have such good results. So that one I would not recommend. ZGC for the very experimental ones out there might be a thing that could be interesting. We don't officially support it yet, but I hope we get there at some point in the future. One thing that we have done, so in the very early days, you could run any development environment. And then we had support for IntelliJ and Eclipse for a long time. And I think every couple of months, something broke weirdly in Eclipse. And one of our engineers that was still using Eclipse had to spend like a day or two to fight some obscure error messages. That's why a while ago, we actually gave up on official Eclipse support. And I think pretty much all of our engineers have moved over to IntelliJ by now. So the only supported development environment that Elasticsearch supports anymore is IntelliJ, and you need at least 2020.1. Though we have so many people working with IntelliJ and on the Elasticsearch code base that we have one or two people who are very close to the kind of like development of development environments. They always run a preview release of IntelliJ. And once it is released, they will tell everybody, well, it's okay to upgrade and it will work because we've tested the pre-release, or no, don't upgrade yet to that new IntelliJ version because we ran into these 5 other bugs. And we have actually filed quite a large number of IntelliJ bugs over the years. So we are a bit stricter. We only officially support IntelliJ. I think we still have somebody working with Emacs on our code base, but that's just a personal preference, and you're kind of like on your own to some degree if you're using one of these development environments then. One of the questions that we quite frequently get around that then is Kotlin. And I don't know for you in the audience who is a Kotlin fan or not, but we have for Elasticsearch, we have not added Kotlin yet, at least. I don't think there was a serious discussion around that. I think for 2 reasons. First, Apache Lucene, the library that we build on, is also pure Java. So we kind of want to stay aligned to that since it makes sense. Yes, you could add Kotlin just in some pieces of the code, but we didn't feel quite convinced. For the second reason is because over the years, different languages on the JVM have kind of like come and gone, and Java has stood the test of time quite well. So for example, 10 years ago or so, you might have started to do a lot of Groovy in your code base. From today's perspective, if you have a lot of Groovy, it's maybe more of a weird sign, or it's definitely not something that is very common or attractive. Like, I don't know, 8 years ago or so, maybe you would have done a lot of things in Scala. And again, from today's perspective, do you really want to have a large Scala code base, and how common is that? probably a bit more common than Groovy, but still, it's not really where the industry is headed or where most of the code bases are, and lots of people would be keen on jumping into that. That's why we have also with Kotlin been a bit conservative. I feel like Kotlin found a better place and is also like doing better and for a longer time than both Groovy or Scala. But also sticking to the kind of like plain Java has served us well in the past. And since now with the more frequent release cycles of the JDK, Java is also catching up quite quickly and adding a lot of interesting features. So we, at least so far, feel very okay with just sticking to plain Java. I don't know if there will ever be a point of adding Kotlin, but it's a bit like the discussions in the Linux kernel where it was C, C++ for very long times. And then there was this discussion of adding Rust. And I think at some point they decided to allow components in Rust in the Linux kernel. But they also skipped a lot of other languages that come and go or have been coming and going. And we've been kind of like following the same approach for Kotlin. Like so far we have steered away from it just because the Java has been working well enough for us and for historic reasons. We see what the future holds, but right now it's only Java. But this is like a common question that people ask, like, when will you start adding Kotlin? Though I'm not convinced it will really solve a lot of the issues that we have. One other thing that is interesting and kind of uncommon in our code base is that Elasticsearch uses the Java Security Manager very heavily, which is very uncommon in Java projects, though it has helped us a lot with Log4j or Log4Shell, which was like December a year ago, so a bit over a year ago, when everything was on fire because of Log4Shell or Log4j. We had a vulnerable Log4j version in Elasticsearch as well, and it had been in our code base for, if I remember correctly, like the last 6 years or so. But Elasticsearch was not, to the largest degree, affected by a remote code execution because we were using the Java Security Manager. So adding the Java Security Manager was a big and painful process. And this was from a talk I did at, I think, Devox Poland a while ago, where somebody asked, like, how much of a pain was it to add the Java Security Manager? And I would say it was a very big pain because we had, over multiple major releases even, we were restructuring the code. So what we have done to a large degree is we have structured the code so that in one package, specific features that need specific access permissions are grouped. And then we could just, through the Java Security Manager, say like, this package can write to disk, and all the other packages cannot write to disk because all the writing of Elasticsearch has gone to this package. And this allowed us to kind of like limit which package or even class in our code base can do what. And this allows us to skip a lot of security issues, because even if you have a security issue somewhere in the code base, it also needs to be allowed to exploit it, basically, to give access to that. So for Log4j, which hit us when we had the the Elasticsearch version 7.16, and this is from our bootstrap checks where we set up the Java security policy. What we allow throughout our code base is the only socket permission we give our code in Elasticsearch is to resolve. So everywhere in the code base, you can do a DNS lookup, and we set a couple of flags. But for example, in our code base, you generally cannot open a socket or a connection. So while without the Java Security Manager, Log4j gave you a remote code execution and you could just load code from wherever you wanted to, in Elasticsearch is what was not a remote code execution, because Log4j didn't have the permission to open a network connection. So it was vulnerable, yes, but you couldn't exploit it because that part of the code didn't need to open network connections and we didn't give it the permission. That's what kind of saved us. So Elasticsearch for network connections under the hood is using Neti. And you will see there are a couple of places where we give in the code the permission to open a socket with socket permission. And that's where Neti is being used. But that's really only a handful of places in the entire code base. that can open network connections, not in our logger, because our logger really doesn't need to reach out to the network and load any code. And that's why Log4j was not such a big issue for us back then, just because the Java Security Manager was tight enough to not allow access to all things all over the place, which is a pain to set up and why it's not very widely used. But for us, it has been a really good trade-off. The downside of not being very widely used is that, unfortunately, in JDK 17, the Java Security Manager has been deprecated in the JEP 4.11. How we are approaching this right now is we still set a JVM flag, coming back to the JVM flags, that says Java Security Manager is allowed. We had a dedicated pull request to add that so that we can keep using that. The other thing that we're doing is we're in the process of replacing it, though we don't really know what the end result will look like, really. For now, we're mostly working on modularization with JPMS. So, for example, we have a meta label in our GitHub repository where you can look at modularization and how code is restructured and grouped together, that we can then add some boundaries of what can do what in the code base. And again, the idea is, just like with the Java Security Manager, that we can reduce the surface of what in the code is accessible or can do things. So even if we have a security issue, it won't be that bad, because that part of the code might not be able to do a network call, or some part of the code might not be able to write to disk. So we severely limit like the impact that any security issues can have. The more work for a full Java Security Manager will be needed, and we're still working that out. I also know that our folks are involved in like discussions with the Oracle folks, who are also kind of like looking at what will potential replacements look like, because the Java Security Manager is deprecated, but it doesn't have a direct replacement so far. We'll see where we end up on that in the future. Coming back to Gradle, which I mentioned kind of like at the very beginning, we have a lot of Gradle. And I always say, don't try this at home, or you probably don't want to do this. So we have almost 19,000 lines of Gradle code. And I think we have like 2 full-time engineers working just on build stuff, which is mostly Gradle. And at least one of them came actually from Gradle. So we have full-time Gradle engineers in Elasticsearch, just because it drives everything. Why do we need Gradle and why do we use it so heavily? We do all kinds of tests. So actually, when we build a binary, some of our tests will actually start that binary afterwards to run integration tests against that. We also do migrations, like version upgrades. So we will start a node in an old version and then migrate it to the current version to see if that migration works. And all of that is directly driven from Gradle, and you can just run it locally with your Gradle build. Which is pretty cool, but that's why Gradle became so large and complex, and has been redone a couple of times over the years. If I remember correctly, actually, Shai started with Gradle in the very early days. It became a mess. They moved to Maven. Maven became a mess and was a bit too limited, and then we switched back to Gradle. I think that was the story, if I remember correctly, though that's like very ancient history by now. But we are very focused on Gradle, and we do a lot of things in Gradle. So you can just run Gradle W run on our code base if you have cloned it, and it will take a while, but it will just run and do what you want. But you can also do more complex things. You can do a run and attach a debugger. You can say, like, I only want to run the tests in this specific package and class, or you could just provide the package. You could only run the tests that have a specific annotation. We do some mutation testing, some randomization of tests, and then you can seed it. So if a test failed through that randomization, if you rerun it with the same seed, it will run exactly the same test. So you can actually figure out what went wrong and solve that problem. All of that is covered by our Gradle setup. And like a task might look like that we start 2 nodes. We say these are the This is how we form the cluster. And this is like the roles the nodes have. So pretty much anything that you can provide in your configuration, we automate through Gradle jobs and actually test that in our builds, which is a complex monster, but it does allow us to do a lot of cool stuff in our builds and catch problems early on. It also means that there's always somebody on duty to look at build failures, because there are so many build failures and things happening all over the place in the code base. And we are using Gradle Enterprise, which I'm not sure is so super widely used, but what we do is, or what Gradle Enterprise is doing, it's caching centrally some modules. And then rather than having to recompile everything either locally on your development laptop or in CI, we can just pull down that build artifact that has been cached, and you don't have to recompile everything from scratch, but you can reuse those precompiled artifacts. And just looking at some of the stats, the build time in, I think, the last weeks or the last week was 17 minutes. Serial execution was 52 minutes. And for example, what we have saved, and I think this was in all builds, is like 6 minutes with which a large enough developer base and CI base. This is saving serious money, both in developer time waiting on builds, but also our CI infrastructure having or running faster. So this is quite a good trade-off for us. And you can see the overhead of the build cache, just to check if you need to download anything, is 7.5 seconds. Then downloading dependencies for approximately 15 seconds on average, but it does save us quite a lot more time during the build. So this is totally worth it. And also looking at the builds just for Elasticsearch in the last 7 days, and this was already from October, but the numbers now should be pretty similar. We had in 1 week about 52,000 builds, and the cumulative build time was almost 700 days. So yeah, every minute that you shave off that build is turning into real savings for engineers, but also build infrastructure. And our build infrastructure, this is then, of course, expensive to run in CI on a constant time or constantly. So this is saving real money. And Gradle Enterprise for us was, from what I've heard, a very good investment and made everybody quite happy. So to wrap up, and now is a good time to prepare your questions as well. Since this is a Java meetup or a JAG, we probably won't have to go over this, but one of the questions that I keep getting in other environments is always like, when will you rewrite in Golang or Rust or whatever other language is popular in a specific circle or at a specific time? Yeah, I don't think we will rewrite in Scala. Stephen, let me finish up on Rust, and then I'll come back to Scala. So when will we rewrite in programming language X? Probably not anytime soon. And to a large degree is we're building on Apache Lucene, and Lucene is 21 or 22 years old by now. And it has seen a ton of optimizations over the years. Elasticsearch is over 12 years old. And it has also seen a lot of optimizations and improvements over the years. You cannot simply rewrite all of that in Rust or Go or whatever in a year and make it much faster. This will just not happen. It's like the number of person years invested into that code base is too large. And the number of features and optimizations are also like on a very high level. So just rewriting is not going to solve your issues. Also, the JVM keeps improving enough that I think we're pretty excited about all the changes that are coming there and how we can push further with the JVM, that rewriting in another programming language is even less of a choice, even though we never really seriously considered it. It's just funny when you look at Hacker News, and then it's always like, X is the rewrite in Rust or in Golang or whatever. And everybody gets very excited about that. And we're always like, yeah, you can do that, but you don't really have to. But it's nice if everybody gets excited about that. Talking about Scala, we also have a cloud service, which is Elastic Cloud. And they started many years ago because it was the hype back then with Scala. And they have a lot of Scala. And then they did a lot of Java. And then at some point, it was very hard to onboard new people to Scala, because Scala can be complex and it's not as widely used anymore, but also because Scala has these different ways of writing almost, that some people use Scala more as a more enhanced version of Java, and others use it as a very functional thing. So you have very different styles and code bases. And at some point we had this, or we tried to replace Scala with plain Java, but we never saw that project through. So we still have Scala in that code base, and it's maybe not the best thing to have. Also for onboarding and in tooling and everything, it just makes your life harder. So we have suffered for our cloud service quite a bit with Scala as well. And I mean, by now, of course, it has Go for proxies and other things as well. So it's a complicated piece of software. It has grown over the years, whereas Elasticsearch itself, having always stuck to plain Java, has a surprisingly consistent code base, I would say, or it's much easier because it's like one ecosystem and one tool that you need to have installed and master. And that makes it a lot simpler overall. So Java has served us quite well. I'll come back to the other question in a bit. Just as a reminder, because I think this is kind of uncommon in the Java ecosystem, is that we always bundle the JDK and always the latest version. So the day JDK 20 or 21 or whatever comes out, we will change that. We also always run with the preview JDK release so that we can catch bugs early on, and that we also escalate that back to the JDK team, because we really don't ever want to be stuck with a JDK release when something changed in a bad way for us and we catch it too late. That's why we always run with previews to get the feedback in early, to know what is coming our way, to make sure we are on the right path for that. And then we're always bundling the latest stable JDK with Elasticsearch to make our lives easier and yours more performant. And that's it from my side. Now is a great time for questions. So let me stop sharing, and I'm happy to dive into any questions that we have. So,
okay.
Also from Steven, what are some of the biggest JVM learnings that Elastic has encountered in the code base? One thing that I have not been talking so much about is compressed pointers, which is probably the first thing to configure. And this has been a bit of a pain point to some degree. So is everybody familiar with compressed pointers? So what you have in Java is, depending on how much heap you have configured, your pointers can be shorter or longer. And so we always recommend to have a heap size of up to less than 32 gigabytes. I think on most operating systems is actually 30.5 gigs. Then you have compressed pointers. Otherwise, your pointers will be longer. And we don't recommend doing that because A, it needs more CPU because longer pointers mean longer or more heavy calculations. And B, longer pointers also need more memory. And we really don't want to do that. Or to catch up, you basically need to go from 32 gigs of memory to 40 or so. Only then will you actually have more memory free than not. So that is the recommendation. And then what is the right heap size has been a very heated discussion for us. So we never configure a heap larger than 30.5 gigs of heap by default. And something that we have been, I don't want to say flip-flopping, but moving around is like, what is the right default heap size if you don't set it explicitly? And we highly recommend to set the heap size explicitly. But if you don't, by now, we will take 50% of what you have in the container or instance where you're running Elasticsearch, because we assume it's the only process running there and you want to give it all the memory. So we take 50% for the heap, and the other 50% is left for the operating system and file system level caching and all other stuff, which works very well if it's the only process. However, it does always cause friction if people try to run 5 different services on one server. And then Elasticsearch takes 50% of the heap, And then people complain like, oh, it's such a big, heavy service and the JVM is horrible because it takes all the memory. And we were always like, yeah, but it just tried to make a guess. And was the best thing we could figure out. If you want to have a different heap size, set the different heap size explicitly. In earlier versions, we also had dedicated heap sizes or like explicit heap sizes. So we said, I think at some point 4 gigs, and then we said 2 gigs. But nothing was really the right heap size ever. So you really should configure your heap size explicitly to make that work the way you want. And of course, larger heaps are not always better. If you don't need the heap, don't configure it. Your garbage collections will just be faster and simpler if you have a smaller heap. So if you don't need a large heap, don't configure a large heap. It's just kind of wasteful. And I always feel like it's giving Java a bit of a bad reputation almost, that it uses so much memory just because it's the way it is configured. I mean, in other things that bugs, we probably had any kind of bug that you can think of. I think that the most joy you always have around TLS and certificates. And that is probably its own full talk of like how to generate certificates and manage them with the JDK and or your operating system. I don't think we had a lot of like total paradigm shifts. I mean, there are like from there are industry-wide paradigm shifts. For example, when Elasticsearch started, you had some medium-sized machines where you were running everything. What is the current architecture trend right now, for example, is to store data for data stores on Amazon S3 or any compatible layer, just because it's in storing data cheaply in large amounts is just, that's the best option probably. And you want to decouple compute and storage to some degree. But that wasn't there when we started Elasticsearch. And it's not super related to Java now, but it's just like these architectural approaches change a bit on like, depending on how hardware changes. For example, we haven't really gotten into GPU, like graphic cards processing, because I think the programming model with the JDK is not super great yet. On the other hand, because it's probably not as beneficial for a data store as in maybe, I don't know, mining Bitcoins or doing other things. So while I think there are these paradigm shifts, I don't think we had complete shifts. It's more like you do something, you keep iterating on it, and then you need to see the change through. We have made some bad decisions early on and then suffered through those for a long time. So I think there's also kind of old history by now, but one of the very painful things we had was dependency injection in Elasticsearch. And we used Juice, the GUICE, Juice, the dependency injector from Google. And for some reason, and nobody really remembers anymore why, we didn't use a dependency, but we forked the code base, and it was a hard fork into our code base with some customizations that was then totally unmaintained and was rotting away. And it made life really hard. And we basically had a multi-year effort to dejuice our code base we're only doing manual dependency injection or wiring anymore. We don't use automated dependency injection with Juice or anything else, just because we have suffered so much through that. And because we want to be very sure what is actually the dependency that we are calling where by now. So I think that was one of the learnings that you probably have in many large code bases, is that you want to make things explicit and don't want to have too much automated magic happening, just because that automated magic is great when it's small and you have an overview of everything. Whereas if it grows and you don't really know what's happening anymore, it will make your life much harder. So we have definitely learned our lessons, and then those were very long-term projects to invest into to make them right. It's a bit like dejuice, properly use the Java Security Manager. Those were things that were hard and important, but they did make a difference in code base. Otherwise, I think something where the JDK ecosystem is not getting enough credit for is that we started writing Elasticsearch, or Shai started writing Elasticsearch 12 years ago. There's probably still quite a bit of code from back then in the code base. And that totally works with the JDK. If you're in many other programming languages, you have so many breaking changes or things have to be rewritten on a constant basis, that would not be a thing. Whereas the long-term perspective of Java has always been very good. Whereas if I look at Kibana in Node, I think that has been rewritten 3 times over completely, because on the front-end side, it was Angular at first because everybody had to do Angular. And then we switched to React because everybody has to do React. And then you change everything to TypeScript because that's kind of like the trend. Whereas in Java, like, yes, there are new constructs that you can add, but the code that was written 10 years ago will still work today and is still getting us far. And that's, I think, a very underappreciated feature of the JDK ecosystem, or Java itself then. That it has a very long-term vision to keep a project going. And I think we have reaped quite a few benefits off of that. I hope that answered the question, Stephen, to some degree at least. Any other questions?
So I actually am curious too now with AI, machine learning. So how does it affect, right, in Elasticsearch? I'm just curious. You
mean for writing code?
Yeah, or writing code, or even like the runtime if you're incorporating like machine learning type of strategy, right, for doing search and that type of stuff. I haven't worked with it. I'm just more curious at this point, right? So,
so I feel like there are probably multiple answers to that. So first off, so far we had the policy that all the code in Elasticsearch needs to be written by a human, and you cannot use any AI to write the code for you. Also because the origin is sometimes a bit questionable, and then you might get something in a license that you don't want, or you might have a trademark infringement. We might have to change that because I think as an industry, things are changing quite rapidly. But so far, we have a policy of not allowing any AI-generated code. There is another thing that we might want to look at some point. I think tuning JVM parameters could be, I'm not sure if that is full AI, but there could be like a machine learning model to actually tune the JVM for your use case and actually change the parameters, which we haven't really explored that much, but I think that would be something interesting.
Sure.
And then there is, of course, for search, there is AI or semantic search or vector search, like there are all these current trends. And yeah, for vector search, especially, and bringing machine learning models to search, for example, to have an image and extract like features from the image, we are implementing quite a lot of stuff. So for that, there is stuff happening. It's just not kind of like in the Java code base yet. But so I feel like AI is changing the industry very widely, and like there are so many different layers to that. But for core search itself, yes, it is there and it's changing. For the Java code itself, we'll see.
Okay, cool. Thank you.
Anecdotally, by the way, we answer a lot of technical questions, and people started to try to use ChatGPT to answer their problems. So I've seen recently a blog post where somebody ran through some very common Elasticsearch errors, ran them against ChatGPT and said or took the answers from there. And I have a half-written blog post by now because those answers were pretty bad, actually. which is interesting because I know it can do pretty cool stuff, but it also shows that just because some bad answers were repeated quite a few times, ChatGPT kind of like learned the wrong stuff. And then it's kind of like repeating the wrong things. And the other problem that is often happening is that if something changes, like the knowledge is kind of like outdated, it will give you a recommendation that might have been a good recommendation 1 or 2 years ago. But because things changed, it doesn't give you the right recommendation anymore today. And then, of course, you always have the problem of like it gets the context wrong or it doesn't quite understand what's going on. But I've seen quite mixed results in that. But that's again, it's total separate discussion then.
Yeah, that's right. Cool. Yeah, thank you. Yeah. So this is all we have for today. And if you have any more questions, please feel free to turn on your camera or audio. I'm still here for a little bit. And then if, and I think it's already late for Philip, but I guess if Philip is still around too, you can answer something. But otherwise, I'm staying a bit here for a little bit longer if you, yeah. So, yeah. So with that, this is the end of it, of today's meetup. And thank you so much again, Philip, for having presented a great talk. And I'm just going to stop the recording as well. And thank you again for joining us today.